Assalamualaikum and a very good morning to Dr. Muhammad Fakisan bin Romli. My name is Emilia Aisha and we are from Group 22. Today, we are going to present our project which is Selantik Coal Mine Explosion Sri Aman Sarawak. Let me introduce our group members. First and foremost, Nur Shuhada binti Sugianto from Chemical Engineering. Me, myself, Emilia Aisha binti Muhammad Zahir from Materials Engineering. Thirdly, Yasmin Zalika binti Abdullah and Nurul Ain Shafiqah binti Muhammad Marzuki from Petroleum Engineering. Now, let us move on to the introduction part. On 22 November 2014, an explosion occurred at Selantik Coal Mine Pantu, Sarawak, killing 4 workers and injuring over 30 others. Underground coal mining is highly hazardous due to flammable gases, confined space, and limited escape routes. Mine depend on ventilation and monitoring system to control dangerous gases. The accident involved methane gas, which is colorless, odorless, and highly explosive in confined tunnels. The incident highlights the danger when natural hazards interact with operational failures. Moving on to the discussion on the topic, 2.1 Overview of the incident. The explosion happened during normal mining operations at about 9 a.m. A faulty ventilation fan caused a short circuit, producing sparks that ignite methane. The confined tunnel system intensified the blast, causing severe burn injuries to the workers. 2.2 Methane accumulation and explosion dynamics. Methane is naturally released during coal extraction. It accumulates near tunnel ceilings when ventilation is inadequate. At 5 to 15% concentrations, methane becomes highly explosive. 2.3 Ignition sources and coal dust amplification. Electrical sparks, hot equipment, or friction can ignite methane. Coal dust can trigger secondary explosion, increasing the blast intensity. The disaster resulted from methane buildup, ignition source, poor ventilation, and tunnel confinement.
Hello, I'm Shahada. I'll be explaining about the technical or engineering issues related to Engineers Act. Based on preliminary investigations, the explosion was believed to have started from a spark produced by faulty electrical equipment, most likely a ventilation fan motor located 69 meters inside the mine tunnel. Since underground coal mines often contain flammable methane gas, electrical system in these environments must comply with hazardous area classification standards. This issue is closely related to REA 1967 under Section 7 and 24A, which only registered professionals such as professional engineers, graduate engineers, or engineering technologies are legally allowed to perform engineering service in Malaysia. Therefore, any failure in equipment design, inspection, or maintenance may indicate a lapse in professional engineering responsibility. The second major issue was the accumulation of methane gas inside the tunnel, which suggests possible deficiencies in the ventilation system design or monitoring. After the explosion, methane levels were recorded at around 20%, which is extremely dangerous. Engineering standards require methane levels in coal mines to be below 1.5%, with oxygen levels of at least 20% for safe operations. Under Section 8 of REA 1967, only a professional engineer with PEPC or ECP is authorized to submit and approve engineering designs and reports. This requirement ensures that critical systems are properly designed and reviewed by qualified professionals to protect workers and maintain safety.
My name is Yasmin Zalika, and I will continue with ethical reasons for failures related to the Engineers Act. Firstly, the Selantik coal mine explosion demonstrated a clear violation of engineers' duty of care. Engineers have an ethical responsibility to prioritize the safety and welfare of the workers and the public. However, investigation found that the explosion was caused by sparks from a defective ventilation fan that ignited the accumulated methane gas, which allow faulty equipment to continue operating in a high-risk underground mining environment, shows a serious breach of safety responsibility under the Engineers Act 1967. In addition, the damaged electrical system after the blast created further risk of secondary explosion. Secondly, the incident also reflects a failure in engineering judgment. The mine had been operating for about 8 years with over 100 workers, which require consistent engineering supervision and safety monitoring. In coal mining, methane gas level must be continuously monitored to prevent explosion. However, measurement taken after the blast showed methane concentration reaching around 20%, which is within the flammable range. This indicates weaknesses in ventilation system, gas monitoring, and overall risk management within the mining operation. Finally, the disaster also raised ethical governance issues related to transparency and accountability. Engineers and organizations have a responsibility to investigate failures openly and learn from them. The victim included workers from several different countries, which highlights the importance of ensuring equal safety protection for all the workers. Following the incidents, authorities launched an investigation under the Occupational Safety and Health Act 1994, where the mine operator could face fine or imprisonment if negligence was proven. I think that will be all from me. Thank you.
Next, for the recommendation to prevent future problems related to engineering acts is first, redundant ventilation and monitoring systems. So engineers must design ventilation systems with full redundancy to maintain airflow during fan failure. Next is to install real-time methane detection systems in strategic tunnel locations, and lastly to integrate monitoring systems with the mine's electrical network. Second is professional conduct and safety compliance. As we know, engineers must prioritize safety, health, and public welfare, and we must implement zero tolerance for defective or uncertified equipment and allow engineers or supervisors to stop operations immediately if hazards are detected. And lastly is intrinsically safe electrical standards. So electrical equipment in methane zones must be intrinsically safe or flame-proof. Then we have to follow recognized explosive atmosphere safety standards, and lastly to conduct regular certification and maintenance checks. Lastly, for conclusion, the 2014 Selantik coal mine explosion was a preventable disaster caused by mechanical failure and poor safety management. Methane gas accumulated to dangerous levels because of the ventilation and safety systems were not properly maintained. So we as engineers must ensure that technical systems are safe and do not put workers' life at risk. The mining industry must promote a strong safety-first culture through proper maintenance and hazard preventions. And the most important responsibility of engineers is to protect human life and prevent future accidents. So that's all from our group. Thank you.